All right, good morning, everyone. Sorry for the delay. This is the second lecture on ecosystem classification. This is the last lecture just to help you guys use OLIS's classification system. I'm going to go through a lecture on some of the important different classification levels that we use to help us classify different types of resources that we use in the environment. Okay, so this is back to classification. Remember, the reason why we're starting with classification is simply because we want to make sure that you understand what it is that we're working with. If you can identify the different types of water resources, you'll be able to understand what makes them so special. You'll be able to understand what you need to do to conserve them. So again, let's just see what's happening. Again, just to re-emphasize that this classification system that you need to learn for Conservation 102 comes from this classification system for wetlands and other aquatic ecosystems from the South African National Biodiversity Institute. This is the manual by OLIS that was published in 2013. You guys need to be able to use this. Okay, we're going to refer to this a lot during our practicals as well, but I will test you on your ability to use this manual to be able to classify ecosystems. So I really encourage you guys to get it off, to download it off Moodle and to go through it so that you can see how it works, how to apply the different levels. Remember what we discussed is the classification system is based, is based on these 6 levels. And when you classify, you move from each level as you decide what type of system you're dealing with. And the way that this classification system works is that it can either only be an inland or estuarine or marine ecosystem. Once you identify that it's an inland system, you then decide what is its ecoregion. You can also consider, does it have any FEPA groups? That FEPA, by the way, refers to the National Freshwater Ecosystem Priority Areas. Okay, that's what FEPA means, and any other frameworks. Then you decide within the landscape, where is this ecosystem? And that's what I'm going to work on today, is just some of these two. So in terms of these regional settings, this is the second level for aquatic ecosystems. We prefer spatial frameworks for the identification of these regional scale ecoregions. Some of these ecoregions have been established by within South Africa to help us determine what the ecoregion that it is that you're working within, all the water management areas, for example. Other layers are available from Southern Africa or the whole of Africa. And when they consider these broad ecoregion scale classification categories, they generally consider the physiography, ecosystem dynamics, climate, geology, soils, and vegetation. And this is an example of one of these ecoregion classification systems that are used. So this is a classification system. The lights don't seem very good. Ooh. Wow, I like this video. Better. Or all of. Okay, so this is pretty cool, hey? So these are the different ecoregions that were based on topography as well as the catchment areas. And you can see what you have is the different colors are named primarily on the ecoregions, and also consider some of the major river ecosystems that occur there. For example, the top left you have the Zambezian headwaters, the Zambezian floodplains, right down to this lower Zambezi, and then down into, what is that, the lowest lake. Yeah, it's all based, and then the Zambezian Lowveld. Let me rather do it from here where I can see. Have I got a button here? Here we go. That's better. Okay, so you can see these are often based or named on the different catchment areas that the Zambezian headwaters. Here's the Etosha catchment area. But then you get these Namibian coastal plains. You get the whole of the southern temperate highveld, the highveld region, this whole region, the Cape Fold region, the whole Karoo, the Western Orange, that would be based largely on the Orange River, the Southern Kalahari, the Kalahari, main Kalahari itself. You can see there's the Okavango floodplain, Zambezi. So these are the the ecoregions that are available for us to say that that area, that whole region can be typified. It's got unique characteristics that we would be able to use to say, based on its geology, you would expect similar type of ecosystems to occur there. What's important for us, guys, is to show you that we are over here in the low veld, and you can see that we're all part of this larger Zambesian low veld. And this also brings reference to the fact that there are influences of the Zambezi system that have extended all the way down to this part of the country. And we know that because of some of the species that occur here. Within South Africa, we also have our own ecoregions. This is level 1 ecoregions. And here you can see that we've further unpacked the different ecoregions, the landscape types into the Limpopo Plain, Soutpansberg area that's up here. And then number 3 is important for us, which is the low veld. So we often refer to the low veld as an area. And that's based on the altitude of the low veld, but also because of the characteristics of this clay type environment. And that's where we all live. So that's why you know that they refer to the area that we live in as the low veld. So this is important for you guys to be able to identify what type of major ecoregion you live in. And importantly, for example, if you look at the different grassland areas, it helps us to identify the differences between Sana ecoregions, bushveld ecoregions, and then different grassland ecoregions. And again, the characteristics of the different systems that occur within those different places could somewhat be comparable. And that's why it's important to understand what your ecoregions are. If you look at the whole of Africa, this is a map of the ecoregions that have been established for the whole of Africa. This is again at a broad level. And you can see again this whole Zambesian ecoregion, which is very dominant and very influential in our part of the world. And you can see it extends right down to the Limpopo catchment over here. Kalahari Highveld, you can see those sands over there. That dark green one is the Afrotropical Highlands. You can see that over there. And then I just want to show you that East African coast zone is that zone that runs all the way down the East African coast to the point of the base of the East African coast. So can you see that there's lots of overlap? In other words, if you use the African ecoregion level, it would be slightly different to the Southern African ecoregion level, which is more detailed. And even that is not as detailed as the South African ecoregion level 1s. We even have a South African ecoregion level 2, which is a lot more detailed. So all you need to do is to specify what ecoregion framework you're using to classify the different types of systems and to do the comparisons. Why is this important from a water resource perspective? Because if the characteristics of your system are comparable, you can compare what's happening in a river here to a river that's happening in the same ecoregion. So if you compared what happened in the Crocodile River to what happened in the Sabi River, it would make sense. They're connected, they have similar species, similar features. But if you try to compare what's going on in the Crocodile River to a system that occurs in the Cape, we'll say you're smoking. You understand me? Okay, that's the reason for understanding, the reason why it's important to know where these different ecoregion levels are. How do you know where you are? You can look at maps, but that's not very accurate, hey? It's very difficult to see exactly where the boundaries occur if you're standing in Mbombela and you're trying to use a map like this. So what do, guys? We use GIS. Have you guys been exposed to geographical information systems yet? GIS. And that's what we use. We use GIS to tell us where we are. Easy peasy. All right, then if we move on to South Africa, in addition to the different ecoregions, we have these water management areas. You remember we spoke about these water management areas. So in South Africa, we had these 9 water management areas, and then we moved from these water management areas because we decided that they were too coarse, and we changed it and we moved into 19 water management areas. Well, we struggled to manage that as well. So at the end of last year, we decided to go back to the 9 water management area system. Okay, so these are the 9 water management areas in South Africa. And you can see that we're in the Umkomati Usutu Pongola catchment management area. And then you can consider, for example, if you look at the Limpopo Olifants, that's one large catchment, but it's been divided into 2 water management areas. And one of the reasons why we separate into 2 management areas is not only because of the catchment boundaries. You see that this conforms to the catchment boundary over there. But it's important that we consider what type of use activities exist within that catchment area, and what are the regional towns, and who's managing those areas. So you can't take water management area 1 and 2, which is the Limpopo and Olifants, and combine it together and then say that Mariko is going to manage it. You understand? The small town of Mariko, for example. You also can't say that because Johannesburg occurs in the catchment, or Pretoria, we're going to use Pretoria to manage the entire water management area, where eMalahleni is a big issue with mining and agriculture and pollution impacts on the Olifants. Okay, so there's a bit of a social, economic consideration that's come into deciding what are these water management areas in South Africa. But it's important that you guys know that you are a part of the CON102, actually, water management area, which is being managed currently because these distributions have just been changed last year by the IUCMA, the CON102 Catchment Management Agency. Okay. So what's important just to know at this point, guys, is that we have these different water management areas, and according to the law in South Africa, we should be assigning the management of those areas to catchment management agencies. Why would we do that? Why would the government itself not just manage the water management area itself and all of them, all 9 water management areas? Why would we do that? Why would we ask the CON102 Catchment Management Agency to manage it for us? You see, I told you I would start to bribe you. Okay, first one goes to anybody who gives me a go. Anybody. Why would the government give away the responsibility of managing a catchment to an agency? And the agency consists of a few government people, a few private people, a few locals. Why would we do that? Anyone? Why doesn't the government manage everything? Anyone? Come on. Ross, oh, he's trying.
I guess it's because not all government officials have the knowledge to those resources, so they need also private.
Okay, he said it.
The private.
He said resources. Resources. It's so difficult for us to manage everything, and we're not going to do it well. We don't have the resources. So what do? We divide the areas up and we say, okay, you look after that. Why do you look after it? Why would I say that the people who live here are the ones who should be managing this resource? He's going into his bag again. Coffee. It's a coffee one. Oh, but this green one looks better. Eh? Why? Why should it be important that you let the people who are living there manage the resource? Yes. No. Carry on. What else? What else? Someone in Australia. Trying to find. What else? What else? What else? Come on, keep going. Because they know the place better? More than that. Yes. Yeah. Karen? Why do they know how to do this? They are the ones who rely on the resources. They are the ones who rely on the resources. Understand that? So it's important that you allow the people who are going to be affected by the management to do the management. You with me? All right, so what we've done now is we've looked at these water management areas, and the next step we've done is we've actually divided them up into their catchments. Can you see that this map looks a little bit neater, where you can see all the rivers that are flowing in different areas have got a white boundary around it. So these are the coarse Hydro 2K water management areas, Hydro 1K water catchment areas. Okay, Hydro 1K. What that means is the government has actually delineated the catchments and given them names. So you can see that from catchment area 1A all the way to catchment area, where's it? it probably goes round and ends at X. So guys, whenever we refer to some of the work we're doing, we're going to refer to our catchment, the Usutu catchment, as catchment X. That doesn't mean it's because it's the unknown catchment. It's because it's been given the name X. So the catchment numbers that the Department of Water and Sanitation have established for this catchment is called catchment X. Everything we refer to, if I say to you guys, we're dealing with a river ecosystem issue in catchment A, then you should be able to go and look and see exactly where it is. You with me? Okay, and we're going to be dealing with catchment area X. And that's going to improve as you go along. You'll see how we will use the classification system. So these are the catchment areas of South Africa. Okay, back to landscape units. Yes? Just because it gets very confusing when you've got numbers. 1.2, 0.3, 0.4, 0.5, point whatever. You understand? You even get a speak for asking. Okay, so we use the, sorry, it's coffee, but I mean it's early in the morning, so that's okay. So we use those letters. Okay, we're going to talk about that in more detail as we go into the field. Now, let's look at the level 3. This is based on topography within the catchment, and what we consider here is the valley floor, slope, plain, and bench. You know, these different areas within the landscape units. Okay. Okay, this is based on the topography and where you are from the top part of the catchment right down to the coast. Okay, we're looking at the different parts of the catchment. What's important to consider here is there can be 4 types of landscape units. When you use this manual, you must go and look at what are the different options you have. What are the 4 categories you have? Make a choice. Make a choice. That's all you have to do. Okay, if you consider these landscape units, all of them have got definitions. So what is a valley floor? A valley floor occurs at the base of a valley, usually in low-lying areas that are situated between 2 distinct valley side slopes. So you have to have 2 slopes that actually create the valley. Without the slopes, you cannot have a valley. If there were no slopes, it would be a flat plain. You with me? In the valley floors, the alluvial or fluvial. Alluvial means the movement of soil. Fluvial means the movement of water. Processes typically dominate. So the processes that move soil and move water and the movement of water through the valley is a dominant characteristic. Okay, the movement through the study area. Because it's confined, there's nowhere for everything to go but through. You understand that? If it's a confined valley floor. Slope is an inclined stretch of ground. Okay, so if you look at this picture over here, it's quite small. Let me go back one and look there. Here is the slope. Can you see that over there? Here is the slope. It's the mountain and the slope down the side of the mountain. Where the valley floor, you can see what usually occurs in valley floors. You usually get rivers in valley floors. But in slopes, what about slopes? Whoopsie. They are inclined stretches of ground, typically located on the sides of mountains, hills, or a valley, not forming part of the valley floor itself. The slope landscape unit can be further divided into scarp slopes, mid slopes, and foot slopes. Okay, there's just 3 types of slopes. Please go look at the classification manual. Please go through the manual to see what those 3 different types are. Okay, and then the plain. So what happens when you leave the valley floor? You enter this plain area. Okay, so it's no longer the valley floor with 2 mountains or 2 slopes on either side. What happens when you enter the plain? It is a low-lying level area, gently undulating. Undulating means that it can move up and down. Okay? Undulating waves is when you get this type of movement in the waves. Or uniformly sloping land with a very gentle gradient that is not located within a valley. Okay. For this, by the way, I would give you 3 marks. Low-lying area, gently inundating or uniform, not within a valley. You understand that? Okay. And because I wouldn't be nasty to you, I would ask you this question out of 2. So you can get one of them wrong. That's how it works. You understand? Okay, what is a bench? Let's go back to our picture and look at a bench. Okay, this is a bench area here, hey? Can you see that? So the side of a mountain, you get these flat features that are relatively high up. They're not part of the plain. They're not part Okay, bench is a discrete area. Discrete means that you can see it. The whole area can be defined. The difficulty with a valley floor is that it goes on forever. It's hard to say exactly where it is unless you're looking at a satellite image. A plane opens up and goes out forever. A bench is not like that. A bench can be easily defined, which means it's much smaller. Mostly level or nearly level high ground. High ground means altitude relative to the broad surroundings. Includes hilltops, saddles, and shelves. And these are, yeah, I think we've got a description just now. Benches are usually small, less than 50 hectares in area. I said that they're small because they're discrete, that you can see where the whole area is. So you can tell, if you stand there, you can say, I'm standing on the bench. I can see it. If this area is massive, then it's not a bench. Then it has to be a hill slope, or you're moving towards plains and things like that. You with me, guys?
Yeah.
So a little bit too early today. Yeah, he's happy now. He's got coffee.
Yes.
Exactly. Okay, a hilltop bench occurs at the top of a mountain or a hill and is flanked by downslopes in all directions. Okay, these pictures are in your manual as well. Hilltop bench. A saddle bench is similar but flanked by low slopes. You know, like a horse's saddle. A horse's saddle, you have the saddle area that you sit in. Okay, that's why it's called a saddle, because it's a bench, but it's got on the flanks, on each side, it's got a slope, a heel slope. Okay, so you need to just understand what these different types of ecosystem types are. A saddle bench, okay, is similar but flanked by downslopes on opposite sides in one direction. Okay, a shelf is sometimes called terraces or ledges. They are relatively high-lying topography or with the altitude. They're high in the catchment areas. Localized flat areas along a slope representing a break in the slope with an upslope on one side and a downslope on the other side. That just means that where you get these rocky areas, these very rocky areas, everything around the rocky area can erode, but you get this rocky shelf that forms, and you have a definite upslope and downslope with the shelf. When you see those movies with those people walking along those roads in the mountain, and they're walking on the edge of the mountain, there's an upslope, the shelf, and the downslope. You see, that road that looks like a road is very similar to what a shelf looks like. You with me? Okay, so you need to be able to go and look at the map. I'll show you what the manual looks like, that you can see the pictures of each one. Okay, please get used to going through your manual. Now we move on to the different types of zones of a river. So although Ollis's classification provides you with the different types of features within the landscape, what a lady named Kate Roundtree has done is she's looked at rivers, and she's taken the same type of landscape delineation for rivers, and she's established these keys to differentiate between a source zone, which we just refer to as S. So a source zone of a river is a part of a river system that is very hard to define. Okay? It's low gradient, high plateau, upland basin, which is able to store water. It's spongy, peaty, it has characteristic soils of a wetland, okay? And vegetation of a wetland. But it's the source of the river. It's hard to say exactly where the channel is because it's coming from all directions. Okay, that's the source zone. Then you get the mountain headwater stream. And I'm going to introduce this to you now, guys, because later on we're going to talk about different types of river ecosystems. And one of the most important things about river ecosystem is that it changes along its length. Okay, so along the length of a river, you can generally characterize headwater streams, which is very steep gradient, dominated by vertical flows over bedrock, lots of waterfalls, plunge pools, fast, first or second order systems. We can talk about that if anybody has a question, but I'm not worried about first, second, third, fourth orders. First order is the main stem. Second order is its first tributaries. Third order is those tributaries. Okay. Reach types typically include bedrock fall and cascades. Lots of fast-moving water because you're up in the mountain. Steep. Okay. Mountain streams, then the gradient starts to, so the mountain headwater stream, then the mountain stream, so the gradients start to reduce. Still dominated by bedrock boulders, usually cobbles, coarse gravels, and pools. Reaches typically include cascades, bedrock falls, steep pools, approximate equal distribution of vertical and horizontal flow components. So it's not the headwater source area, the mountain headwater stream, it's the mountain stream, that's B, and then you move down to transitional areas. Moderate steep stream dominated by bedrocks and boulders, typically include the plain bed, pool, riffle, rapid, pool riffle habitats, confined or semi-confined valleys. So you're starting to get away from the mountainous area where it's flowing very, very, very fast, and it starts to slow down into this transitional zone. Okay, when we're in the field, we're gonna talk a lot about what zone is this. Okay, and look at the descriptions again. Upper foothills, moderately steep cobble bed. So you can see these different classifications are based on the substrate types, the gradient of your river, and the habitats that you find within your river. Oh, ma'am, I thought you had a question with that stretch. It's close, you almost got a sweet. Okay, lowland rivers. Okay, then we move down to upper foothills, lowland rivers. And you can see that the different characteristics of the system change. That in the upper fast areas, you get a lot of high velocities. You can move these big boulders. As you get down towards the lowland rivers, can you see the velocity slow down? And you don't move these big boulders anymore. You start to use the fine sediments. You can only move the fine sediments. So somewhere along the river, all the big boulders and rocks and things, they settle out and they sit on the floor. And that also helps you identify what type of river ecosystem, what zone you're working in, okay, by the habitat characteristics. And that's quite consistent until people start to change things. So if you start to cut all the forest down from the natural forest on the top of the mountain, what could happen is you could start getting erosion. And as the erosion starts to occur, you're going to start smothering a lot of your habitat types. As you start to abstract the water, the amount of water in the system reduces. The carrying capacity of the system reduces. The amount of sedimentation and buildup in your river goes up, and you get your habitats that start to change. So why is it important for us to know, under natural conditions, what the habitat zone would look like, so that you can understand how the system is changing to the way that we are using the system? Okay. So if I am currently in a lowland river, it should look like a lowland river. It shouldn't look like the mighty Mississippi or the Zambezi River in flood. It shouldn't look like that. Okay, then we start to ask the questions, why does it look like this? Has something happened? Okay. That's how it works. Okay, that's the lecture. I'm just going to open the manual and show you the manual for a few more minutes. How much time do we have? Okay. Damn, man, what the hell?